Hi, in this video we'll learn about uses of pointers. Pointers are called as address variables. They store the address of data. So they are useful for indirectly accessing the data. So for learning that, first let us understand how our program works. Quickly we'll understand how our program works. If you have a program, we want to run it, then the program must be loaded in the main memory. The main memory is divided into three sections: code, stack, and heap section. In this example, I have taken a program with some variables. If I want to run this, then the program is loaded in the main memory in the code section. Once the program is loaded, it will start executing line by line. Once the first line is executed, the first line is having the declaration of variables. So the memory for the variables of a program are allocated. And the block of memory allocated for the program or a function is called as activation record. And the important point that I have to discuss here is this memory in the stack is directly accessible by the program. Suppose the address of this location is 500 and this is 502 or 504, then this A will be replaced by 500 and B, instead of B, it will be using the address 502 and so on. So the memory inside the stack is directly accessed by the program or a function in a program. Anything other than stack is accessible by the program indirectly, not directly. Only the stack memory is accessible by the program directly. Suppose the program wants to access the memory present in heap, then it cannot access this heap memory directly. Let us see what it has to do for accessing heap. Now here, first usage of pointer is accessing heap. Here I have taken an example where I have a pointer and using malloc function I am allocating 10 bytes of memory in heap. So this is the function for allocating memory from heap. Once the program is loaded in the main memory, the activation record is created and it is having only one variable, that is P, so the memory is allocated. Now when the program executes this instruction, malloc function, the memory is allocated in heap and the address of that location, let us say the address of very first byte is 1000, so that 1000 is stored in the pointer. So the pointer will be pointing to this heap memory. So that's how the program can directly access the pointer, and from the pointer it will take the address of heap and it will access the heap memory. Heap memory is not directly accessible, but it is indirectly accessible by the program. So this is the first thing where pointer is used. Second example, pointers are useful in call by reference. For that, let us take an example. Here I have taken one example where main is having two variables and I want to swap their values with the help of swap function. Here the main function is calling swap function. Swap is taking variables x, y and is trying to swap them. I think this will not work because these are simple variables. This will be call by value. Let us study this, then we'll go to pointers. Once the program is loaded in the main memory, main function will start executing. Once the main function starts, the memory is allocated for variables in the main function, so A and B. Then main calls swap function. Here main calls swap function. Then once the swap function executes, the memory is allocated for variables in swap function, like for x and y and t. And the values of A and B will be copied here. When the swapping of these two values is done, then it is done within the swap function only, because this function cannot access the data present inside the activation record of main function. This activation record belongs to main and this belongs to swap. So one function cannot access the data of other function or the activation record of other function. This is the limitation. So this is not going to work. If I take simple variables, then the swapping will be done within the variables of swap function itself. Then we'll modify our swap function. Here a swap function will take pointers as parameters. So let us see how it works. Once the main function is executed, the memory for main is allocated, and when swap is called, then the memory for x, y and t is allocated. And here you can see that I am passing the addresses of a and b. So if the address of a is 500 and this is 502, then the addresses will be passed to x and y. So these x and y are pointers pointing to these variables of main function. Using these addresses, swap function can swap the values of a and b. So we can see that swap is indirectly accessing the variables of main function. So these are pointers are used for indirectly accessing the variables of other functions. Next usage of pointer is accessing files. If you want to access files, that is read or write the data from disk, then for accessing this file, pointer is required. This pointer can access the file on the disk. Like in C programming, when we want to access any file, open any file, we need a pointer, file pointer. So without pointer, we cannot access a file on the disk. So pointer is used for accessing data on external storage. Next, accessing peripherals. If a program want to read the data from keyboard, or if a program want to write any output on monitor, if a program wants to write anything on the printer, or a program want to access a file on a disk, for anything, any of this operation, we require a pointer. So for all these operations we require a pointer. Though in C language we don't directly access all these peripherals, we use the built-in functions like printf or scanf for printing or reading the data from keyboard. But these functions, printf and scanf, uses pointer for accessing these devices. So finally, we can say that pointers are useful for accessing the data present in any other device or any other location apart from the stack, because only the stack memory is directly accessible and the data present at any other location is indirectly accessible. So for indirect accessing, pointer is useful. So pointer plays a key role for accessing the data outside stack. Here is the list of usages of pointers: accessing heap memory or call by reference, accessing files, or accessing any peripheral. Hope you liked the video. Thank you for watching.